Hey everyone, it's that math magician, and on this video we're going to take a look at arithmetic sequences, and more importantly, how to write a recursive equation for an arithmetic sequence. Now, if you've been watching these videos, in the previous ones we looked at how we could write an explicit equation. Well, there's another way we can write that equation out as, and that's as a recursive equation. Basically what it boils down to is a recursive equation is a way to write out a sequence when you know the term before the one you're looking at. So let me go ahead and give you an example for this, show you how we can write out that recursive equation and how we can use it to find additional terms in our sequence. Let's go ahead and focus on the sequence 5, 11, 17, 23, and then I'm going to put 3 dots or an ellipses there, indicating that that sequence does go on forever. So we have this sequence here, it's arithmetic, and what we want to do is we want to find out a way of writing this, not as an explicit equation, but as a recursive equation. Now remember, for explicit equations, you need the zero term, and you need the common difference. Well, for our recursive equation, we're still going to need our zero term, and we're still going to need our common difference. Those two facts don't go away. We still need to find those two important pieces of information. So for the common difference, same idea that we've been using. We want to look from our first term to our second term. How are we changing from the second to the third, from the third to the fourth? How are we moving in that sequence? Again, if you can't recognize it just by looking at the sequence, that's fine, because we do know another way to find out that common difference, and that is you pick one of your terms in the sequence. I'll go ahead and pick 11, and then we just need to subtract 11 by the term before it. So we're going to take 11 minus the term before 11, which is 5, and that will be able to tell us our common difference. Well, 11 minus 5, that makes positive 6. So our common difference here, as we move through this sequence here, is plus 6. 5 plus 6 gives you 11. 11 plus 6 gives you 17. 17 plus 6 gives you 23. Perfect. We now know our common difference. The other piece of information that we need to know is the zero term. Remember, we denote that by saying t of 0. And again, the zero term, what that's referring to is up here, we see that 5 is the first term, 11 is the second term, 17 is the third term, and 23 is the fourth term. What we're trying to find out is that zero term right before our first term. And we found that out in another video. An easy, quick way to do that is to just take your first term, which is 5, and subtract your common difference. Our common difference is 6, so we do 5 minus 6. That lets us know that our zero term here is negative 1. Those are the two pieces that are going to help us develop our recursive equation. Now, the recursive equation and the explicit equation are similar, but then they're also different as well. Now remember, with an explicit equation, we start off that equation with t of n, kind of like f of x. That's how we start the explicit out. But for a recursive equation, we're not going to start with t of n. Instead, we're going to start with t of n plus 1. T of n plus 1. Now what that is saying is you are looking at a value in your sequence, but you're looking at the one in front of it. For example, if I'm looking here at the second term, that n here represents my 2. Well, since it's n plus 1, if I'm having n equaling 2, that means I'm looking at 2 plus 1. I'm trying to find out the third term. Now, to find that third term, I'm going to use my second term, the term that's right before the term I'm interested in. Well, if I'm looking at t of n plus 1, then I'm going to just use t of n. T of n here is referring to the term we're looking at. We're looking at the second term. I need to take that second term, and what we need to do here is we need to add our common difference. That is the generic formula for a recursive equation. Let me go ahead and write that out. This is the recursive equation formula for an arithmetic sequence. This just says, and I know we might get tripped up a bit by this n plus 1. Understand that what this is saying is, if I'm looking at the second term, let's say I'm looking at n equals 2. If I take that second term, I add our common difference, I will get our third term. Let me explain that out to you. Let's look at it. I'm going to take this equation here. So for us, we're going to have t of 2. T of 2. I'm looking at that second term. So n equals 2. I'm going to take that and I'm going to add our common difference. Well, we know that our common difference here is 6. So I'm going to take t of 2 and I'm going to add 6 to it. If I do that, I take my second term and I add 6, I will be getting the third term. I will end up equaling t of 3. So please don't get tripped up too much over this n plus 1. All that's referring to is I'm taking my second term. I can use that second term to help us find the next term, the plus 1 term, the third term. So here's how we use it. What's t of 2? I look up here. That is 11. So we take 11 plus 6. 11 plus 6 ends up equaling 17. So by using the recursive equation, we find out that our third term is 17. Now, of course, we can see that just by looking here, but that's the benefit of using the recursive equation. It's a bit more simpler than using the explicit equation. Now, let's say I wanted to find the fifth term, right? We don't know what the fifth term is yet by looking at this sequence here, but to find the fifth term, what my recursive equation says is that I need to take my fifth term and I need to take the one less than it. If I'm looking at the fifth term, I'm taking the one that's less than it, t of n. In this case, we need to look at the fourth term, and we're still going to add our common difference to that. So to find my fifth term, I take my fourth term. My fourth term is 23. Add the common difference to that. 23 plus 6 ends up equaling 29. So I now know that the fifth term in this sequence is 29. Now I hope you're understanding that the main benefit of the recursive equation is you can find the next term, but you got to know the term before it, right? If I'm trying to find the fifth term, I got to know the fourth term. If I'm trying to find the 10th term, I have to know the 9th term. If I'm trying to find the 100th term, I have to know the 99th term. For recursive equations, you always have to know the term before the one you're trying to find. So you can understand that there's some limitations to this. I wouldn't be able to right now, using this formula, I won't be able to find t of 100. If I was trying to find t of 100, I would have to know what t of 99 is to add 6 to that value. So that's why there's a difference between when we want to use explicit equation and when we want to use the recursive equation. You only want to use the recursive equation if you know the term before. If you don't know the term before, you are better off using the explicit equation. Now the only thing left here that we have to do, again, that's our formula for the recursive equation. You'll notice that I did make use of the common difference, but I haven't yet used this fact about the zero term. Now, just by looking at this recursive equation, we see that to get the new term, we take the old term and we add 6. But this does not give us a starting point. Nowhere in that recursive equation does it tell us where our zero term is. So to use n to use a recursive equation, you have to make sure you give the reader, whoever you're working with, the information of where your equation starts. For us, our sequence starts at t of 0, so next to our recursive equation here, we also have to let the reader know that t of 0 equals -1. If we tell the reader that t of 0 is -1, then they'll be able to find t of 1 by putting in t of 0, adding the 6, and generating their sequence. That's what recursive equations are. It's a different way of writing out the sequence. It'll still give you the same sequence if you're using the explicit equation. It's just another way of reimagining that equation. Alright guys, it's that math magician, and I'll see you on the next video.